Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about one machine learning solution designed to enhance user experience. This topic is based on a tech blog with the title How We Personalize Recommendations for Professionals on Thumbtack, written by their applied scientist team. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved.
What is Thumbtack and what does professionals mean in their blog?
Thumbtack is an online marketplace that connects customers with local service professionals, or pros, to get various tasks done. With over 300,000 active professionals and serving millions of customers annually, Thumbtack bridges the gap between demand and supply for services. For example, customers can find pros for plumbing, electrical repairs, wedding photography, and personal training on the platform. The key players in Thumbtack's ecosystems are the pros offering their services and the customers seeking tailored solutions for their specific needs. Thumbtack is currently a private company with an estimated valuation of $2 to $3 billion, underscoring its significant impact on the service marketplace industry. The platform's business model focuses on facilitating these connections while empowering the pros to showcase their skills, to grow their business and reach new customers.
Thumbtack offers services to people, but why do those professionals need recommendations?
That's an excellent question. For professionals using Thumbtack, it's not just about listing their services. It's about finding effective ways to grow their business. These professionals are always looking for strategies to increase their visibility, to attract more leads and boost their bookings. In a highly competitive marketplace, professionals optimize their approaches by expanding service categories, adjusting pricing, or targeting new geographic areas. For example, a wedding photographer might receive a recommendation to expand their service categories by offering engagement photoshots or event videography, services that are closely related to their original expertise. Thumbtack's recommendations are crucial for helping them identify methods to achieve those goals. Its ability to provide tailored recommendations not only helps them to expand their business, but also contributes to the platform's overall growth. When professionals succeed, they are more likely to remain engaged and generate increasing revenue for the platform as well. Now that we've understood the business problem to solve, let's shift our focus to the existing solution Thumbtack had in place and why it needed improvement. Initially, Thumbtack's recommendations for professionals were ranked based on product intuition. This meant that the same ordering of recommendations were applied to all pros, regardless of their unique needs and goals. While this approach was easy to implement and allowed for quick updates, it failed to account for the diverse preferences and business objectives of individual pros. Treating all pros equivalently resulted in suboptimal experience. Recognizing this, the team hypothesized that each pro has distinct preferences, and a static set of recommendations would not suffice. So they aimed to prioritize and personalize those recommendations to tailor them to each pro's unique circumstances. This new direction involved leveraging machine learning to surface timely and valuable suggestions. With this direction established, the team began building the machine learning solution. The first step in building the machine learning solution was to track and store those relevant informations that could serve as features for their personalization model. This is also important to test the team's hypothesis of how professionals engage different recommendations. This involved added tracking for key recommendation metadata, such as position and rendition. Position signals capture where the recommendations were viewed, clicked, and enabled, while rendition signals tracked what recommendations were rendered to a specific pro at a given time. Since some of this data was not accurately tracked in the past, the team used the proxy data as a starting point to validate their hypothesis and build an initial model. Step 2 was to construct the machine learning model itself. The team's goal was to rank recommendations based on their estimated impact on lead volume, which refers to how much the recommendation is likely to contribute to a pro receiving more job leads. This ranking was derived from two subcomponents: the likelihood that a pro would enable a recommendation, and the expected lead volume generated upon enablement. By combining these factors, the team could prioritize recommendations that were not only appealing to pros, but also highly effective in driving business growth. The first model is called the personalization model, which predicts the probability of a pro enabling a recommendation. This binary classification model used a tree-based approach, with a label of 1 indicating the pro enabled the recommendation and 0 otherwise. A tree-based approach in machine learning involves creating a decision tree or a set of decision trees, where the data is split into branches based on feature values. This method is highly interpretable and efficient, making it ideal for classification tasks like predicting whether a recommendation will be enabled. The second model, called value-giving enablement model. It estimates the expected lead volume for each recommendation type upon enablement. These two models worked in tandem to produce rank scores for each pro recommendation combinations. The team estimated the expected increase in lead volume using a fixed effects modeling approach. This approach works by modeling the outcome of interest, in this case the lead volume, as a linear combination of various fixed inputs, such as recommendation type and pro-specific characters. By controlling for unobserved variables that could vary between pros but remain constant over time, fixed effect modeling isolates the effect of each input on the outcome. This method is particularly useful in scenarios like Thumbtacks, where individual pros may have distinct, stable attributes influencing their response to recommendations. With those two submodels built, at inference time, predictions from both models were multiplied to generate a final ranking score, which prioritized recommendations that would most likely result in increased leads for each individual pro. The team decided on using offline inference with a weekly refresh cadence due to the nature of the recommendations and the pros' engagement behavior. Pros typically use a carousel at a lower cadence compared to more well-known carousels like those for content or movie recommendations. While super real-time activity tracking and inference could improve performance, it was deemed unnecessary for a first attempt for the personalization. Instead, the team adopted this more practical and cost-efficient approach to meet the business need. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored Thumbtack's business model and the importance of recommendations in helping professionals grow their businesses. We shared insights into the machine learning solution architecture, which involved building two submodels and deploying them using offline inference to meet the business needs in a cost-efficient manner. This quick and nimble approach to machine learning solution demonstrates how technologies can effectively solve real-world business challenges. If you like the content of this episode, please subscribe to the channel. Give us a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.